Hello, everybody, and welcome to Sparing Partners. As you know, we talk about different things, and today we're talking about innovation. Innovation specifically related to AI and power consumption, but we have a little bit of a broader frame. And I have with me today, our guest is Paul Patras. He's the co-founder and CEO at NetAI. And he's also a faculty. He's a professor of mobile intelligence at the University of Edinburgh. It's a title that I'm very envious of. We'll figure out what that means. He is in an excellent position because he's just on both worlds, academia, research, and actually having a startup where he's doing things. Not that people in academia don't do it, but there is the research part and the innovation and product part. And he has that very, very interesting work. So we're going to talk about the latest. So Paul, why don't you tell us who you are and what is mobile intelligence anyway?
Yeah, thanks so much for having me, Monica. It's always a pleasure to catch up with you and talk about things that we've been working on recently. So where should I start? So I'm an engineer by training. I did a PhD in telematics engineering, which is a cross between telecoms and computer science, and then I ended up on the academic path, and then just before the pandemic, we realized some of the work we were doing in the lab had commercial value. We spun out, and right now I wear two hats. I think the NetAI hat is the bigger one, but I still have an involvement with the university, just to kind of make sure that I'm not falling behind in terms of what happens in terms of research that might be perhaps a few years ahead of the curve and not really kind of ready to be commercialized just yet. So what does mobile intelligence mean? So when I thought about it, the way it works, the way the academic system works in the UK. So when you apply for promotion to professorship, you basically you become a personal chair, and you get to choose the title of that chair. And because I started this line of research at the intersection of mobile networking and artificial intelligence, I thought, well, we're basically building AI for mobile networks. So it just seemed fitting to call it mobile intelligence. So yeah, that's sort of the title I decided it would be appropriate for my professorship, for my chair, and the university was quite happy with my progress up to that stage, and I was awarded that title.
Excellent. Now, why don't you tell us what is NetAI, what NetAI does, which is a bunch of things.
So NetAI is a network intelligence company. We develop what we believe is cutting edge AI that is tailored to the mobile networking domain, that enables mobile network operators to basically maximize the value of their deployments. We developed a suite of AI-driven insight systems. We have one of them, which we're probably the most proud of. We have a cutting-edge forecasting engine that simultaneously solves for energy efficiency and profitability, in the sense that you're not going to switch off resources based on some forecasts at the cost of hardening service quality, which is a big issue for the telecom industry. So that kind of maintains that profitability aspect, but also we're trying to forecast incidents, well, actually anomalies before they become incidents. So that sort of maintains customer base and mitigates churn to some extent. So yeah, that's where it comes from.
Excellent. And today we're talking about a special part of what you're doing is the work you started doing with Arya. And I think this is interesting because, we're going to talk about how innovation is driven for startups that obviously have a difficult situation in terms of, you need funding and help from the government. How is that working? And in the UK, there is this agency that is working on it. So for those that are not familiar with it in the UK, or most of them not in other countries, can you tell us about what is ARIA, and then we'll move on. What is that you do for that agency?
Mm-hmm. Yeah, so ARIA is a relatively new funding agency. It stands for Advanced Research and Invention Agency, and it sits under the Department for Science and Innovation. And yeah, unlike the other sort of, let's say, more traditional agencies, so for instance, you have UKRI, which is probably the largest one, which is the UK Research and Innovation Agency. ARIA is trying to fund more kind of, let's say, breakthroughs, both in science and, in technology, with the aim of basically, benefiting society. And they run multiple programs, and every program has a program lead. And things vary from very fundamental things such as mathematics for, safe AI, all the way to kind of more applied aspects such as, for example, robotics, or even things to do, for instance, with how do you do modeling and how you do potentially interventions to address climate change problems.
Yeah, and I think that this is actually quite interesting because in the past we thought of innovation as technological innovation straight out, but now I think that the whole sort of improving society becomes much more relevant, where we can use technology. Well, I guess we always could have, but it's becoming more, how can I say, more realistic and more practical to use it, more effective to use it for, say, energy consumption, but also with AI, we have all sorts of ethical issues. They're not actually, most of those issues are not new, but they are, they become much bigger. So, privacy and all that is nothing new, but with AI, we get all sorts of much bigger issues. So I think that, it's a very interesting way to frame innovation, not as its own, for its own sake. It's not 6G for the sake of 6G. It's how can we make 6G help us to do things better. So I think that
Yeah,
this is, it's it's not that's, I mean, it's actually very important to think of innovation that way.
yeah, I agree. I mean, we talked about this previously. So, you eventually you need to do some fundamental research that sort of lays foundations for bigger problems. But oftentimes, I mean, irrespective of who the funder is, be it a government agency or a private funder, and you have even like philanthropic organizations that will fund fundamental things. But eventually, people are trying to solve a problem, right? Even if you're doing fundamental stuff, you're thinking about, hey, look, there is a crisis in an area, and I want to develop, some new methodologies, some new tools to try to address those problems. I mean, if you want, climate change is probably a big one, and it's quite abstract, right? It involves so many things, and there are things that you can do, including with AI, to get a better modeling of the whole sort of planetary system, which is extremely complex. And then you have all the tooling, and you're thinking about, how can I think about, let's say, circular economy in that sense? So instead of, disposing of things and just like building from scratch and handing a lot of the materials, for instance, in construction, ending up in the landfill, can I reuse them for, let's say, rebuilding something or repurposing them? So, and that's to some extent his tooling and his processes and his methodology. So I think, you can look at research kind of across a bigger, kind of a broad spectrum, from a very fundamental stuff all the way to very applied stuff. And I think ARIA kind of, I mean, again, it's a new agency, but to me, it seems pretty nicely organized, and the way the programs are organized, because they fund both fundamental things and then both applied things. So the work we're doing right now is in this program called Safeguarded AI, and there are multiple technical areas, and one of them is the actual scaffolding, all the mathematical properties that would verify, would basically look at some, formal guarantees of the operation of a model, and then you have applications. That's another task, and that's what NetAI is working. And of course, there is ample scope for cross-fertilization between technical areas. So you're working on something very applied, and every now and then you will have a workshop. We had a workshop 2 weeks ago, and you're speaking with hardcore mathematicians, and you're trying to understand whether you can provide more solid, say, formal proofs that what you're developing actually is doing what it's meant to be doing. So it's quite exciting, to be honest.
Yeah. So what is that you're specifically like net? I mean, I guess it's net AI doing. I mean, is
Yeah.
the so what is that you're specifically doing? Because okay, so we talked about the sort of general, but let's talk about in practice. What is that you're
Yeah.
doing? How is that you're
Yeah.
working on?
Okay, so let's approach this kind of top down, yeah. So what's the problem that we're trying to solve here? So if you look at mobile networking, probably all your audience is familiar with this. I mean, telcos now account for over 2% of carbon emissions. Energy costs are outpacing sales growth, so it's a big problem. And with the expansion of 5G, you need to build more and more sort of resources, more capacity, denser networks. Probably 6G will, even amplify that trend further. That means even more energy being consumed. So the bigger problem we're trying to understand here is how to basically reduce energy consumption, actually revolutionize the way in which you save energy, especially in radio access networks, which are the sort of the big beasts that consume 80% of the total energy consumption in a deployment. So that's kind of the big prize. Now, to get to that, there are some, if you want, some building blocks to kind of overcome. So one is, okay, so what our approach is, and I think a lot of other people in the industry are following this, it's okay, you forecast demand and then you do something with that information. So you're trying to understand, what resources you could switch on and switch off, and you can, come up with some policies, be them rudimentary, rule-based, or you could use something more fancy. But eventually, you also want to safeguard the operation of that infrastructure, because again, it's critical. Yeah, it can be, providing some services that are of very high value to businesses, to individuals, and so on. So to some extent, that's why kind of was relevant to ARIA, because the program is about safeguarding AI. So now we were trying to see, okay, we can save energy, but how much energy we can save without compromising service quality. And then if you go a layer even deeper, so you're building AI, right? So an AI will be as good as the data that you use for training that model is. And one thing that we realized when we started our journey with NetAI was that, operators recognize that, sharing data will eventually boost innovation, because you have, new entrants in the sector that develop new models, that those use AI, and those will need a lot of data. So, okay, fine, we should be able to share data, but then data is value. So there is a little bit of reluctance. Yeah. So there's a little bit of a kind of a conflicting sort of standpoint, if you want. How much can I share? And to some extent, should I share or I shouldn't share? I want to innovate, but I don't want to, give away any sort of commercially sensitive information and so on. So we said, okay, that's fine, but we can maybe try to build an AI that overcomes that data sharing barrier. So if you want, in a very sort of a crude way, you have some really great data that Net AI or Nokia or Ericsson or whatever will need to train, a, let's say, a tool that comes up with a policy to save energy. Great. But you don't want to share that data. So what we can do is say, hey, look, we give you a box, you train this box on your premises with your data, you give us the box back, and now this box can generate synthetic data that looks akin to what happens in your deployment, but it doesn't reveal any sort of sensitive information. So that creates opportunities not just for Net AI to, train a model, validate that model, and so on, but now it kind of creates opportunity for other people as well, who could basically use that synthetic data to probably even come up with better ideas and better solutions. So in a way, it becomes like a key building block that can boost innovation, across the industry, not just for a certain player, in this case, us.
Yeah.
Does that
So
make
this is
sense? Yeah.
Yeah, no, and this is actually very interesting, even beyond the AI, because traditionally, what would happen is that you have the Ericsson, Nokia, Huawei that have actually access to multi-operator data because they work with them. And so they
Mm-hmm.
basically would just do something like that without using AI or whatever. But then it's a closed system. Now, as networks open, you need to I said you need to share data, and not only it's operators' data, but it's also vendor-specific data. So that in
Mm-hmm.
order to get a system that works, you need to have data probably from different vendors, and so
Mm-hmm.
it's really important to have uh, a way to share data which everybody trusts. So it's how can I say it's becoming a way to actually enable more open networks too. Not just a
100%.
so
Yeah.
it's a good for AI, but it's also good for openness, right?
100%. Yeah. And also, I mean, you touch on a really key point there. So let's say, startup X enters a potential partnership with the, CSPY. Um, CSPY said, well, we would like to share you some data with you, but we are sort of locked into a vendor, and we really don't know how to do that. Um, so there's that challenge in the sense that, okay, if there is a technical barrier to kind of extracting that data, having synthetic data as a sort of a proxy to be able to train a solution. And I mean, if you want, you're like even sort of building a behavioral digital twin of a deployment. You're overcoming data sharing, probably access to the data from a technical perspective, like all the challenges that come with that. And secondly, it gives you also the option of, evaluating a range of solutions from multiple vendors in a safe environment before deciding what to deploy in practice, because eventually you don't want to disrupt their day-to-day operations. Okay, I want to let this run for a while in a contained environment without actually pressing any buttons in the real deployment, because I just want to get enough confidence that this will actually work to my expected standards before I roll it out in production. So I think there's potentially many benefits to this. But then again, it's AI, it needs some data. So to be able to
Yes.
kind of validate the whole concept, you do need some friendly partners that actually are interested in, sharing some of that information. I mean, we have some data we can use because we have some NDAs with different people, and that allows us to do some sharing. But ideally, it would be great to have let's say, like a telco partner from the early steps to be able to kind of iterate and make sure that the at the end solution is sufficiently uh, reliable and robust and Um,
Yeah,
yeah,
and I guess you want to have kind of a framework to say, well, we can share data and this is a safe way to do it. Because whatever you're doing today, you might decide to do something new tomorrow and you don't want to start from scratch. So if you have like a good framework that we know what we can do, then it's easy next time around. And so, this is, and I've been writing a lot about the fact that, AI doesn't do any, in fact, it's dangerous if you don't have good data because then the thing doesn't work. I mean, it's not because the model is not working, it's because if the input is not right, then,
yeah,
so the synthetic data seems to be actually helpful not only for the sort of safety and of the sharing, but also because it kind of cleans it as well, probably. And so what you get is actually better data than the raw data. Is that also
it's
an
a
element?
valid point. Yeah. So even data sets we had access to so far, um, some of them are, good quality data sets, but oftentimes you end up seeing, like, let's say, missing data points. Let's say some piece of equipment was malfunctioning for a while, and it didn't record any telemetry, or you have outliers, which again are for all sorts of reasons. So typically they're not representative for that sort of, for that day-to-day operation. And if you train a model with all that data without doing any sort of, data engineering, data cleaning, the model will try to learn something from it, but whatever it's trying to learn, it's not, it's not necessarily meaningful. It doesn't really represent the behavior of the system that you're trying to model for 99% of the time. So as a result, it might just, latch onto some patterns that actually are not representative, and actually when it sees things, it will just, make some inferences, some decisions which are not necessarily the best, just because, it just tried to cover too many things and not having enough data points and so on. So it does kind of avoid that sort of initial data engineering step that you normally have to do.
Yeah, and sometimes when you talk to people, you get a sense that people see AI as basically fixing the problem. Like, you throw the data at it and that magically, but it doesn't. You need to actually work on it. And I think that, so to have this like cleansing of the data, synthetic data, it's really helpful in terms of also of the power consumption issues because no, I'm sorry, the argument is familiar that the models will use so much energy that it's actually the kind of energy consumption that you have is it's sort of there is none because at the end the model takes so much energy. But on the other
Yeah,
hand, if you have better data, then you're going to require actually less energy. I mean, it's going to be less complex to train the model because it's better
yeah,
data, less
yeah. So
noisy.
that's true. I think there's two elements there. So you're right, because oftentimes you can think like, okay, let's say take a deployment of the size of, New Delhi, where you probably have tens of thousands of cells. So now you're saying, okay, I want to save energy here. But actually, what I'm going to do is I'm going to train, let's say, a simple neural network for every single cell. So all of a sudden, I have 10,000 models that I need to maintain. And the way you do things in DevOps with like continuous integration, continuous deployment, in ML, you probably do also continuous training. So periodically you verify if the model makes sense, if there's been any changes in the mobile networking, sort of in the traffic landscape, and you need to improve the way those model works, which means retraining, which again is additional computational power and additional cost. So you have an ongoing problem that you probably think you thought, hey, I'm gonna save energy, but you're actually moving the energy consumption from the edge to maybe a more centralized location. So the way to potentially address this is have more scalable models that actually, look at different parts of a deployment at the same time and effectively, I guess that's what we got good at, is how to build this sort of, neural architectures that are tailored to a specific deployment and reduce the number of models that you need to maintain, so you don't move the problem from the run to the cloud. But the second aspect is, yes, indeed. I mean, if you train with a lot of data, it doesn't mean that necessarily the model will be good if the data is of poor quality. So having a sort of a more compact data set that is of the highest quality, doesn't have any sort of, artifacts that actually don't represent anything meaningful, then of course you're streamlining the process, and your training time will be shorter, and that means, less energy being consumed during that training process.
Now let's just move the sort of from the other point of view, the other end. So you have this model, you share all the, I mean, using shared data, and that's a good model that works well. But every operator has his own different needs. Not only that, it's not just the operator. If you look at, let's look at cell sites, a rural cell site and a metropolitan cell site, completely different.
Mm-hmm.
So if it's one in the UK and one in, I don't know, in Saudi or Africa or whatever, whatever other country is going to be different. So how do you go from having a model that it's very good for everybody to having one that it's very good for that operator, for that cell site?
Yes, that's a good point. So what we're trying to do, I mean, of course, I simplified a little bit the problem. So in this synthetic traffic generation process, ideally you don't want to train strictly on traffic, for instance, let's say throughput, because it's easier, no? Let's focus on one KPI. So maybe I look at throughput or PRB utilization. I'm not interested solely in historical patterns of that KPI over, let's say, the past 2 months in different locations. I probably can augment that training process with other information that is even potentially publicly available. For example, population density in different areas, land usage. So all these other, if you want, exogenous variables that provide additional kind of context that will give the model a better ability to understand how, how traffic would look like in a certain context. And then, when you deploy in another location, a different network, as you say, you might use all that context information as an input to the new model. So now the model ideally has, learned from enough data sets from different places, and it has this ability to kind of easily translate to a new setting. So this notion of model transferability would apply. Again, that's our hope at the moment. We still have, 12 months to go into this project, and then we will see if we're going to succeed by the end of it. So that's why I think in this early step, I mean, there's publicly available data that we can use, but having access to as many data sets as possible from as many partners as possible will be key. So yeah, we're trying to work on that.
Yeah, so I have many more questions, but maybe what we should do is in the at the end of the 12 months, we can have another one to see what happened in the meantime. So Paul, thank you so much for sharing your thoughts with us. And as I said, we should catch up soon and find out the progress there.
My pleasure. And yeah, again, it would be great to catch up as things develop. Thanks for having me.
And thank you all for listening to Aspiring Partners, and do sign up and let people know about it if you like our episodes and discussions. Thank you so much.